Yo, this is Mr. O. Yo, this is Mr. O, and today we're gonna learn and introduce to you two-column proof. Okay, two-column proof is another way of learning geometry through proving. But before we go there, let's go with some basic properties that we should have learned already when we were in middle school or algebra one. There's a reflexive property wherein the symbol is A equals A. Symmetric means if A equals B, then B equals A. Transitive property is A equals B, then B equals C, then A equals C. Addition property, if you have A and A equals B, then you add C for both of sides of the equation. Or subtraction property or equality, when you subtract C on both sides of the equation. Or multiply, when you multiply C to both sides of the equation if A equals B. Same thing with division. And substitution, if A equals B, then B can be replaced in A in any expression. Okay. And what is two-column proof? Two-column proof is a geometric proof consists of a list of statements and the reason that we know those statements are true. The column statements are listed in the column on the left, and on the right side are your reasons for which the statements can be made are listed in the right column. Okay, so when you do two-column proof, most of the time in geometry, particularly, you're given there a problem. A given, or a statement that you can use, and you have to prove it that the answer will be whatever is stated there. For example, this one here, in given that 3 times the quantity 2x minus 9 is equal to 9. Prove that the value of x here equals 5. Let's try it. So first, on the left side, we're going to write the statement. And on the right side, we're going to put our reasons. You always start with the given. You always start, whatever the given, drop it, the first one here. 3, 2x minus 7 equals 9. Okay? The reason there is that that's a given. That's what we have currently. Okay? Number 2, if you're going to solve for this one here, you go to distribute the 3 there, right? So we're going to have now 6x minus 21 equals 9. So how did we get 6x minus 21 equals 9? Because we distributed the 3. So that's called distributive property of equality. We distributed there. The next step there is that we're going to add 21 on both sides here. So this will be 6x equals 30. How do you get 6x plus 30 there? You added 21 on both sides. You added 21 here, added 21 there. But you don't have to show the work there. It's something that you should know already. Okay? So plus 21 there. So what did we do there? We did addition property. Property of equality, or APE. The next one here is that we're going to divide here by 6. And if we divide 6 there on both sides, that's going to be x equal to 5. And so what did we do there is division property of equality. And if you notice, that's x equals 5, and that's what you're trying to prove. And the reason is done. Now, Mr. O, what if I did not distribute? What if I divide by 3 first? Can I do that way? Again, the beauty of two-column proof, there are so many ways of doing this. There could be, some of your classmates could have 5 steps. Some of you can have 20 steps. Some of you can have 3 steps only. As long as you do it right, you don't miss any important, relevant statement that is functionable to your previous statement, that should be okay. And as long as the last column on your statement must be the proof that you're trying to prove, okay? And also you must have the right reason for every step that you do, okay? And this is for the algebra. Let's go now for a little bit of geometry, okay? So let's say here that I have angle 1 is congruent to angle 2. We're gonna prove that L and M are parallel. So if we prove that 1 and 2 are congruent, Oh no, if we know that angle 1 and 2 are congruent, then we can say that L and M are parallel. So let's analyze the figure here. We know that we have two parallel lines, okay? L and M are parallel. No, 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 I'm wrong. That's what they're trying to prove, okay? We know that 1 and 2 are congruent. If 1 and 2 are congruent, but you know that 1 and 3 are corresponding. If they're corresponding angles, so therefore, let's say this is 70, this will be 70 also, because they're said that they're congruent, right? That's given. But you know that 1 and 3 are corresponding, so therefore, angle 3 must have a 70 also. Now you have shown that 1 and 3 are congruent, so therefore, as a converse of corresponding angles, then L and M are congruent. Does it make sense? Okay, so let's apply that overview with two-column proof. So first, the given here is 1 and 2 are congruent. So the given is angle 1 and angle 2 are congruent. So that will be my first statement. Angle 1 is congruent with angle 2. That is my given. Again, we know that angle 1 and 2 are congruent. If they're congruent, what else do we know? We know, what do we know about 2 and 3 here? What do we know there? We know that angle 2 and angle 3 are what? They're vertical angles. They're congruent because of the vertical angle theorem. So now we know that 2 and 3 are congruent, and we know that 1 and 2 are congruent as part of the given. What can we say now? What do we know about angle 1 and angle 3? They're also going to be congruent. Look at this portion here, guys. I have here 1 is equal to 2, but 2 is equal to 3. So therefore, angle 1 is congruent to angle 3. For what reason there? That's because of transitive property of equality. If you remember, right here in the beginning, look at transitive. If A equals B and B equals C, therefore A equals C. If R is equal to K and K is equal to T, so therefore, this is the if, so therefore R is equal to T. If you notice, this K here are the same. It was the second statement here, it becomes the first statement there. The B here is the second statement here, but B here becomes first statement. And look at what we're doing here. If do is a second statement here and 2 is the first statement there, they basically, like you can say, cross it out, and 1 and 3 are congruent. So that's because of transitive property. And now we can say if 1 and 3 are equal, they're equal. So therefore, if they're congruent, we can say that L and M are parallel. L and M are parallel. And if you go back, that's what we're trying to prove, that L and M are parallel using a corresponding angle theorem, but with the word converse. Why converse? Because we know that angle 1, we know that if the two lines are parallel, their corresponding angles are congruent. The converse is the reverse. If we know that angle 1 and 3 are congruent, then then the two lines are going to be parallel. Converse is reversed. Okay. All right. Given A and B are parallel, so A and B are parallel, so these two here are parallel. Okay, so that will all right here. A and B are parallel, and 2 and angle 3 are congruent. That will be my given. And let's analyze first the figure. If they're parallel, we know that 1 and 2 are congruent because they are what? alternate interior angles, right? This is the transversal line. And then again, we're trying to prove that 1 and 3 are congruent. But since 2 and 3 are equal according to the given, so now the 1 and 3 are going to be also congruent because look at the structure of the problem. Then I will have angle 1 is congruent with angle 2. For what reason there? It's going to be alternate interior angles, right? And then look at the statement here. If angle 2 and angle 3 are congruent and 1 and 2 are congruent, I can say now that angle 1 and angle 3 are congruent using transitive property of equality. Okay, there you have it. It's very easy, right? We're gonna work on more example of this one next time, all right? And I hope you learned something. As always, kaboom.